number of integers with pop count depth equal to k 1. So we are given with two integers n and k. So n and k, we need to go from 1 till n, and we need to find those numbers which are having depth. Let me tell you that pop count depth. I'll tell you what is this pop count depth is equal to k. Now, what is this pop count depth? So 7 is having 111 in binary representation. This 111 is having nothing but total number of set bits. The next one will be the total number of set bits is 3. So the next number in the sequence will be 3. Now 3 is having the binary representation double one. 1 1. So the total number of set bits is 2. The next number will be 2. Now represent 2 in binary representation 1 0. 1 0. Total number of set bits is 1. So the next number will be 1. 1 is having just 1, so that means it has stopped at 1. Now depth of 7 is 3. I think you got what is this pop count. So I need to know all those, the count of numbers which are having pop count depth is equal to k. Now let me tell you, n is equal to 4 and k is equal to 1. 1 2 3 4. From 1 1 is there itself, so the depth is 0. 2, so 2 is having 1 0. 1 0 is having, that means pop count is 1, so it has stopped with depth is equal to 1. 3 3 is having double one, which will give me 2, and 1 0 for 2, which will give me 1, so the depth is 2. 4 4 is having 1 double 0, and 1 double 0 is having only pop count of 1. What is this pop count? Pop count is nothing but total number of set bits 1, so the depth is 1 itself. Now d is equal to 1 is for 2 times. Why d is equal to 1? Why I'm just counting d is equal to 1? So why? Because k is equal to 1. So that's why I'm just counting how many numbers are having depth of 1. That's all I got. 2. Now n is equal to 7, k is equal to 2. 1 2 3 4 5 6 7, but 3 and then 5 and then 6 are having like double one, 101, 1 double 10, 3 to 3, from 3 to 2, from 2 to 1, 5 to 2, 2 to 1, 6 to 2, and 2 to 1. Why? Because k is equal to 2, I am just taking those numbers which are having depth of 2, and the output will be 3. What will be the intuition? Just take a number. From that number, let me take that I have the depth of k minus 1, not k, but k minus 1. Let me take an example and let me explain you why this intuition works. K is equal to 2. I'm just saying that k is equal to 2. And let me tell you that 100. Let us just take that as 100. Now, from 2, from 2, I can go to 1. What is the depth? 1 itself, which is k minus 1. K minus 1. 2 is represented as 1 0. From 4, I can go to 1 with a depth of k minus 1 again. From 8, I can go to 1 with a depth of k minus 1 again. So imagine, imagine if I knew the number, the number before in the sequence, in the sequence of all these numbers. So what will be the number which will come before 2? That means it need to have set bits. How many set bits? 2 set bits. For some number to be having previous of 4, it should have 4 set bits. For some number to be have the previous in a sequence, given sequence, it should have 8 set bits. I'll tell you how can I achieve this. But wait a second. Now, now let us see that 2 4 8. Is that all? No. Why? Because 2 is having only one set bit. If you see, 2 is having only one set bit. 4 is also having only one set bit. 8, 16, 32, and 64. I'll stop here. Why? I'll tell you in a few seconds. Now I need all those numbers which will lead to the next to 2 in a sequence. Now I need all those numbers which also lead to 4, or I need those numbers which all also lead to either lead to 2 or 4 or 8 or 16 or 32 or 64. Now why why I need only till 64. Why? Because if you see the constants 10 or 15, right, so it is nothing but any number in this range does not exceed does range doesn't exceed 64 bits, 64 bits in binary representation. I'll tell you that these something like 64 bits. From these 64 bits I can represent 10 power 15. That's what I'm saying, right? So I just need 64 bits. And what is the connection between these 64 bits and what I am trying to tell you about these 2, 4, 8, 16, 32, and 64? That means I want to tell you that by only 64 bits. 64 bits. When I say that 64 bits, that means all bits are set bits. All bits are set bits. All bits are set bits. So that I got 64 as the next one in a sequence. So that's why I am taking 64. Now what I need to do with this set, let me take this as valid paths. Now I got valid depths. Let me name it as valid depths, right? So I got all these valid depths. Why is this a valid depth? If a number a number from 1 to 64 is having a depth of k minus 1, then it is a valid depth. So that's what here the intuition is. So I got all those valid depths and I will generate those numbers which will lead to this valid depths. I'll tell you how. Now, how can I generate those numbers? How can I get those numbers which are which lead to any valid depth? Now imagine here, just imagine I got a 3, right? 3 is having double 1. So 3 is leading to 2 and 2 is leading to 1. Now let us imagine 5 which is having 101. 5 is leading to 2 and 2 is leading to 1. So 5 will contribute to our answer. 3 will contribute to our answer. So this is how I get it. I'll tell you, if I have something like 9, I think 9 will give us an answer. Yes. 8, 001 will lead to 2 and 2 is leading to 1. If you see clearly that if I want 4, so let me also go through that. Double one, double one. So this will, I don't know what this value is, but this will lead to 4 and this 4 will lead to 1. And what's the depth here? 2, right? For 9 the depth is 2 and for 3 the depth is 2. For the 5 the depth is 2, which is nothing but k. So I just go through all those valid depths with which are having k minus 1, and I just need those numbers which will lead to those depths with k minus 1. I'll tell you how can I generate get those numbers which lead to any valid depth. That's the most important and most hard part in this question. Now I might have 64 bits, that's it, right? So n is equal to 38. How do I represent it? Now, here comes the actual part of the problem, right? I have this as the binary representation of n. Now all those numbers should not exceed 38. That means it should be lesser than 38. And it should contain a valid thing, but for that I need k as some value. K should be 2. Let me just say that k is 2. Now I need those numbers which are having 2 or 4 or 8 or 16 or 32 set bits. Now let me just generate all those numbers which are lesser than n. For that, how can I generate them? Right? So let us take an example by using this digit dp. I'll tell you what does this digit dp does. First thing, when we use this digit dp, so when we have to count the numbers a range in a range with a specific specific constraint, right? So this digit dp will have some template. I'll tell you what does this template is. It is nothing but int count. So I'll be having a string or something like that, but before that I will be having a position where I am creating or giving this 0 or 1. So it will be starting from 0, right? After that I'll be having tight. I'll tell you what does this tight mean in a few seconds. And then we'll be having some set count or something like that. So int count of ones. For now it is count of ones. Why? Because I need the set bits in the total string, binary string, or in this number, so that I can just get whether it is the total set bits is either 0 or 2, sorry, 2 or 4 or 8 or 16 or 32. Nothing but whether is it present in valid depths or not. So let us see what is this tight mean. Now here we'll be having a base case, of course. Now we'll be having a limit is equal to, if it is tight, it is given as tight. That means if it is tight is true, then num of position will be the limit. If not 1 will be the limit. I'll tell you why it is 1. Now after that we'll be initializing an answer is equal to 0. So for digit is equal to 0 and going till less than or equal to limit, I however will be going from 0 or 1. That's it. Now new type, I'm just writing this template function. New type is equal to type and new type is type ampersand if the current digit if the current digit is equal to limit, then only our new type will be true. So we'll be incrementing our answer by count of position less 1. Type will be new type, and count ones will be incremented if the current digit is 1. So if d is equal to 1, then we'll be incrementing our count ones. I think for now you got it, and return the answer at the end. But what does this type mean? That means I think you might be only confused or somewhat confused with this all. So position and count once you might get it. But what is this type? Let me tell you that I have one double zero double 1 0, right? One double zero double 1 0. First thing I will call with tight. What does this tight mean? So I am calling with tight. That means the first position will be filled with 1 itself. Next positions will be filled with 0, not with 1. Why? Because if I filled one here, if I put limit as 1, then what will be the value? 32 and then 16, it will be exceeding to 48. But the limit, the n is just 38. Then, even though this is giving me 4 and which is a valid depth, I won't consider it. I don't even consider, sorry, make this string. Why? Because this is greater than n. So if it is tight, that means the next position limit will be what I said, what I wrote here. Limit is equal to, if it is tight, num of position. Num of position, here it is. Next position is 0. So the limit will be 0. That means I am going to 1 and place only 0 here. That's it. And when I am placing 0, then the next one will be again 0, right? And the next one can be 1, right? Then the next one can be 1 and the next one can be 0. So this is the one way I can get 30, wait a second, 38 itself. But I got a 0 here, right? Now I got a 1 here and 0 here. Now if I got this, now the next one, something like 5, sorry, again a bit, right? So the next one is also 0. So the next one will also be 1 0 0, 3 positions. Now this is also tight. That means it is nothing but the previous one is 0, then you cannot exceed the limit. Now the next one is here, the next position is having 1. Even if it is tight, I can go and place 0. Why? Because it is even lesser value, right? So I can place 0 there, or I can place a 1 here, 1001 and empty places, right? Now here, is it tight? No. That's what this gives us. This is not tight. Here it was 1 here, but I didn't place 1. Instead, I placed 0. Why? Because I can go from 0 to 1, because here the limit is 1. Limit is 1. Even that there is tight before, the limit is 1. So here it can be 0 or it can be 1. I will also explain you how it works for other digits, like the digits from 0 to 9, but stay tuned. For now, I can get 1001. Now here, is it tight? No. Then I can place 0 or 1 here. I can place 0 or 1 here. 1 triple 0 0 and space 1 double 0 triple 0 1 and a place here. Now here it is tight. Tight is true. So the next value is 1. Even then I have the limit as 1. So what I can do? 1 double 0 1 0 and space 1 double 0 1 1 and space. Now I have the next one as the last one, right? So here I have 0. That means it is not tight. Like limit is equal to, let us see, limit is equal to 1. Why? Because it is not tight. Limit is equal to 1. As I said here, limit will be 1 if it is not tight. So 1 double 0 1 0 0 1 double 0 1 0 1. Now limit, do I have any limit? Yes, it is 0. I cannot take 1. The limit is 0. I cannot take 1. If I took 1, 1 double 0 double 1 and a 1 will give me a value of 39. That's why the limit is 0. 1 double 0 double 1 0. Now here, Here, do I have this limit? Let me check. Let me check. Wait a second. Now here I got one, but I got a zero. So there is no type. So 1000000 1000001. Now here 10001 Do I have a type here? Yes. Here one is a type. So the next value can be till only 0, 1000010. These are all the values, right? But from all these, how many are having, wait a second, how many are having 2 or 4, 2 or 4 or 8 or 16 or 32 or 64 set bits. So for that I am just incrementing counts of count ones plus is equal to, if the current digit is equal to 1, then I am just incrementing the count ones. If not, I'm just I'll just it will give us 0. Now, what's the base case? The base case is if position is equal to num dot size, then don't forget here to include the string num. Num is nothing but string representation of n. String representation of n. Now, if position is equal to num dot size, return valid uh, valid depths dot count ones. If the count ones are having, that means valid depths are having uh, current set bits, current number set bits, then return just we'll be adding this to our answer. Right now here we'll be using a db which will be having for position. Why? Because we'll be using this memoization, right? So bool here for tight, and then we'll be using count once. As I said, everything can be count. So here I'll be initialize with 65, 65, and then 2, as true or false are the only conditions or possibilities. Now, as I said, what if 835 n is equal to 835? Now I'm sharing with you though that problem, like a basic problem in digit db. So n is given as 835, and we need uh, just count the numbers which are lesser than or equal to 835, and having only one digit as 7. So that's what we got here, count once. Instead we'll be using count sevens, and if position is num dot size and count sevens is equal to 1, then we'll just add it to our answer, right? That's what we are given here. N is 835. Now how can I solve this? And the main intuition behind this is to explain you how we use this type. Now type is true, we'll be starting with true. Why? If I didn't start it with true, I'll tell you what it happens. If it is tight, I'm saying that if limit will be, if tight is true, num of position. If not, here it won't be 1, it will be 9, as we are dealing with those digits from 0 to 9, so it will be 9. Let me write it here. So if it is tight is true, then num of position. Now what is this num? Num is nothing but a string format of 835. Now what is this position? Position is 0. Now what is the limit? Limit, as I said, let me change the color for limit. Limit is nothing but num of position, as type is equal to true, num of position, which is nothing but 8. Now digit can be going from 0 to limit 8. So I can have something like something like 035 or 135 or or I'm not saying that I only get 035 135, or I can get 100, or I can get 203, whatever it might be, but I'm just dealing with the first character. So what I just take is 8 and the next two are just empty. Now I can take 0 or 1, or even let me take 7 also, 7 and 8 I'm just taking. I will also go through 0 1 2 3 till 8, but I'm just for your convenience, I'm just taking till 8, just 7 and 8. Now here it is the next one. Next, for the next type, whether we need to make it true or false. Here if you see, the next type I made it as new type, as I made it as type is true and only if digit is equal to limit. Let us see, type is equal to true. That's what I got from the first iteration or first call. Type is true and the digit 8 is equal to the limit. Then here the type will be true, and here it will not be true. Why? Because 7 is not the limit, so it will not be true. So I will be having 7 and uh, position is equal to 1. Here position is equal to 1. What will be the limit? Limit will be, as I said, is type is true? No, false. False. So can be till 9. So the digit ranges from 0 to 9. So I can place 7 0 and something else till 7 9 and something else. Now I got here 8 and the next one I am saying it as type. So here next one I can place here 8, and what I can place here is it is saying tight, right? So if it is tight, it is true, tight is true. Num of position, what is this num of position? Position is 1, num of position is 3. So our limit is equal to 3. And what is the d can be going from? D can be going from 0 till 3. Now I'll be calling 8 0 and empty, 8 1 and empty, 8 2 and empty, 8 3 and empty. If you see, we are not exceeding 835. That's what the main advantage of using digit db. I hope you understood till now, right? If you have any doubts, please don't hesitate to comment in the comment section, right? So yeah, 3 and something, I'm just going through randomly this recursion tree. So yeah, 3 and like this. Now what will be the limit here? What will be the limit here? Here if you see, 0 to 3, right? Only here the type will be true, right? So it will be going from 0 to 3, right? Now so if I place 0 or if I place 1 or something like that, so here only at 3 the type will be true, and I need to go from here, the limit will be changed. But here, is type true? No, it is false, right? So the limit will be from limit will be 9 for 80, 81 and 82. But when it comes to 83, it will change, I'll tell you. So digit ranges from 0 to 9. So it will have 800, 801, 802 until 806, 807, 808, 809. Did any number exceed 835? No. That's what this digit DP works. 810, 811 until 819. Same with this 820 to 829. But when it comes here, tight is true. Why? Because why and how can we say that tight is equal to true? Because if the previous one, the previous which I got as tight, and d is equal to limit, here 3 is equal to limit 3 is equal to limit, so the type will be true. Now what will be digit ranging from 0 to what will be the limit? 5. So limit will be limit will be 5 here. Now let us go through all those digits at the last. 830, 831, 832, 833, 834, 835. Successfully we didn't exceed 835. So this is how it works, and we just need to change these ones or these cases: position, tight, and count ones or something like that. And we'll be using db so that we don't get this recursion stack or something like that, so that we don't get time limit exceeded. And I have given the code link in the description. Go and check it. Thanks for watching this video.